Hello, we're starting to learn about rock slope engineering. I will first give a general introduction to different rock slopes in civil and mining engineering and the applications of rock mechanics in rock slope engineering practice. In later sessions, we will learn rock slope excavation, slope stability analysis, slope support design, and slope protection. Let us start with a general description of rock slope types. Here are photos showing some of the different slopes. On the upper right, it is a natural slope. That is a slope formed naturally and perhaps has been there for a long time. They are forming the hillsides, riverbanks, coast shores, and the cliffs. This particular natural slope forms the bank of the Changjiang River as part of the Three Gorges in China. The slope has a steep dip angle, but it is very stable due to its massive and solid rock mass formation. The upper left photo shows slopes of a surface coal mine. As the mining is progressively from surface going down, it always leaves slopes around the mine. The slopes in surface mines are typically stepped to provide driveways to get down the mines. Slope stability, therefore, need to consider at two scales: the slopes at each step level and the overall slopes of the whole mine. The lower right photo is an excavated and supported slope next to a group of high-rise buildings. It was designed by me some 20 years ago. The slope was cut almost subvertical to make a driveway at its base. However, because of the rock mass, although it is granite but highly fractured, the slope requires heavy support. The supports for this slope were rock bolts, wire mesh, and spread concrete. Please take a look at the drainage holes on the lower part of the slope face. Drainages were provided to reduce the water pressure behind the slope. Because of the high-rise residential buildings on the toe of the slope, on the top of the slope, the loading from the buildings must be considered in terms of slope stability analysis. From time to time, we hear about slope failure and the landslide. The picture on the lower left is a slope after failure. For such large-scale failure, slope failure, sometimes it is called landslide. Landslide often occurs after heavy rain or at earthquake. Rain usually builds up the water pressure in the slope. When the water pressure getting higher, it may push the slope to fail. Landslides can also be caused by earthquake. At earthquake, the seismic wave reflects at the slope surface and produces tensile loads to the slope. When the dynamic loading exceeding the capacity of the slope will fail. Those who climb mountains will see a lot of natural slopes. When you go up and down the hill, you're actually moving on the slopes. Natural slopes typically are the hillsides as those shown in the photo here. The one on the top shows the Alpine mountain slopes in Switzerland, and the one below is the riverbank slopes along the Three Gorges in China. Natural slopes are usually stable and existed for hundreds or even thousands of years. However, due to weathering, erosion, and geological activities, some of those natural slopes may at a critical stage of near failure. That means if they are subject to additional effects and loading, such as rain, earthquake, or other disturbances, they may fail and slide down. Natural slopes are usually of larger scale, for example, as a whole hillside. They, of course, have specific orientations, such as hillsides have different facings. We will learn later that the orientation of the slopes in relation with the orientations of the rock joints is perhaps one of the most important factors in determining the slope stability. Natural slopes are large scale and often in remote locations that are difficult to access, and therefore sometimes it's difficult to support and to protect. Excavated slopes in construction are the slopes that are cut by engineers for specific purposes. For example, for making roads, railways, and canals. Slopes for roads and railways are normally cut as single steep benches, as shown by the photo here. Because of the directional characteristics of road and railways, for example, running north-south, therefore, slopes also have specific orientations. For example, again, facing east or west. We will learn later, given a same rock mass, the excavated slopes can, on the two sides, will have sometimes very different degrees of stability and require different degrees of support. Excavated slopes can also be found associated with building construction and tunnel portals. Again, they are normally single bench slopes, usually supported, as it is part of the important structures. The slopes are often around the structures and not linearly oriented, as the example shown here. Slopes, particularly engineered slopes, if they are potentially unstable and risky, then they are supported or reinforced to ensure the slope are safe. The slope of this photo is reinforced by steel bolts and supported by concrete. Surface mining is to mine the minerals below the earth from the surface. It usually starts with a large open pit, progressively going down to reach the wanted minerals. They can go hundreds of meters deeper. Mining equipment and workers also need to go down the mine. Therefore, the slopes has also served as access driveways to go down. You can clearly see the driveways on the slopes in the photo here. In order to reach and excavate the minerals at depths, surface mines, particularly those in relatively hard rocks, often have very large pits and have large and deep slopes. After mining operation, the pits are usually abandoned because the slopes are not permanent structures of the mine. The slopes are usually not supported. However, it is important to make sure that the slopes are safe during mining operation. Today, the abandoned mines are usually required to be rehabilitated. Then, the long-term stability of the slope in the mines must also be maintained. For economic reasons, the slopes in the surface mines are designed to be stable without any support. The slopes are usually excavated by blasting. The slopes are usually multi-benched and around the whole mine. The bench slopes usually have dip angle up to 70 degrees. The overall slope around the mine usually have inclination angle of 30 to 45 degrees. Those angles, depending on the depth of mines, as well as the slope rock mass quality. Typically, shallow open pits can have a slightly higher overall slope angle, while the deep open pits will have a lower overall slope angle. Slope angle also reduces with decreasing rock mass quality. This is why in soft coal surface mines, the slope angles are usually gentle and the slope heights are relatively low. The typical operation of surface mine of brown coals in Australia is shown here. The brown coals are soft and weak, and they behave like firm soils with very low strength. As we know, net slope angle in soft and weak materials are lower than that in strong and solid materials. Aggregate and rock quarrying are similar to hard rock surface mining. The slopes are produced by rock blasting. Because of the usually high quality of the rock mass, the bench slopes in rock quarries are usually subvertical, with the overall slope angle up to 60 degrees. Dimension stone quarries, such as marbles, are usually cut by sawing vertically. Therefore, the bench slope is vertical. The slopes are usually stable because of generally solid and continuous rock mass. However, it may suffer from rock block and wedge sliding when the joints are oriented unfavorably. We will learn a lot more on block and wedge sliding on the unfavorable joint orientation later when we learn slope stability analysis and the failure modes. So, what is the connection between rock mechanics and rock slope engineering? Rock slope engineering covers slope design, slope excavation, slope support, and slope protection. Let's start with rock mechanics in slope design. When designing slope geometry, including slope height and the slope angle, as we mentioned before, we need to ensure the slope is stable and safe. It is very much depending on the slope mass quality of which the slope is constructed. Strong rocks with a few joints will give the rock mass of high quality and good overall strength that can have a high slope and a steep angle. On the other hand, weak rocks and poor rock masses will limit the slope angle and height. Rock slopes are generally excavated by blasting using explosives. Blasting design for rock slope excavation requires the knowledge of the interaction between blasting and rock strength. The mechanics of rock fracturing and fragmentation under dynamic loading to ensure the effective of rock excavation as well as optimal slope stability. Slope stability is governed by primarily the mechanical properties of the rock mass forming the slopes. To ensure the slopes are safe, we need to analyze the slopes to see if they are stable. If not stable, we then need to design the necessary rock reinforcement and support to stabilize the slopes. The principles used for rock slope analysis and rock slope support are based on rock mechanics. For rock slope to be stable and safe, the rock mass forming the slope must have sufficient strength to stand without any form of failure, particularly sliding along the existing rock joints. Here, joint orientation and the joint shear strength play critical roles in governing the slope stability of joint rock masses. Rock reinforcements are to enhance and to increase the rock mass strength, so the slope can become stable and safe. Rock support is to provide additional structure to help the rock slope to carry the loads. We will learn later, for example, how to use rock mass rating, the IMR system, to analyze the slope stability and to design the slope support. In addition to rock slope support, we often need to design structures to protect people and structures from falling rocks. It involves the impact dynamics of falling rocks and the design of protective structures. For cases that we are not able to prevent slope failure and landslides, then we need to have a plan to manage landslides in order to mitigate the hazards. For example, we need to assess the slope that may potentially slide at earthquake. The assessment is very much based on the knowledge of slope stability subject to earthquake loading, where rock mechanics and rock dynamics form the basis for such analysis. We're also very concerned with slope failure and landslide at water reservoirs due to water level fluctuation. The changes of water pressure in a slope may cause the reservoir slope to be unstable and to fail. Large-scale landslides sometimes will run for hundreds and thousands meters and may damage towns and villages in the nearby areas. Therefore, we need to be able to predict how large the area and how much the hazards may be caused by a landslide, and how to manage such hazards. This requires the knowledge of dynamic motion of rock masses when the slope fails and slides. I will end this session here. In the next session, we will cover slope failure modes and the analysis method. See you later.